Hi, everybody. My name is Ronnie Grapentien, and I will be your instructor for programming and automation in the geosciences this fall. I want to welcome you to this course, back to the semester. And if you're new, I want to welcome you to UAF. This is a really interesting university with not just academic departments, but also several research institutes. For instance, I am an associate professor of geodesy and the geoscience department within the College of Natural Sciences and Mathematics, but I'm also affiliated with the Geophysical Institute, where, in fact, I spend most of my time. Make sure to explore this place while you're here. It's really worth it. There's a lot going on in research, academia, and then obviously this is Alaska, so there's a lot happening that's worth exploring outside of the university. What is this course? We've started experimenting with this kind of course while I was a grad student here at UAF. My motivation then and now is that graduate students and upper-level undergrads in any field, but especially in geophysics, because that's my home discipline, should be intimately familiar with the data processing pipeline, from data collection through data analysis and then visualization for interpretation. This is generally improved through automation of tedious or repetitive tasks. Let's use an example of some sensor, perhaps a seismometer or a geodetic instrument, a GPS receiver, somewhere in the remote wilderness collects data and sends them to the lab via satellite connection, cell, internet, radio links, what have you. Data come from the field into the lab. And you want to look at those data because you're interested in what is happening there. Have there been earthquakes and so forth? The data are collected in non-physical units, some kind of voltage that need to be converted into a temperature, a velocity, or something like that. A physical unit that makes sense and helps you explain or understand those data. Now, these data update daily, right? It is a real-time operating station or some such. You should not have to import them into a spreadsheet, convert them into units, clean out outliers, and make a plot just to see what happened, throughout the time of the last data acquisition. A simple computer code can easily do that for you. The catch is that you invest some time once, oftentimes a substantial amount of time for the development and the implementation of a workflow. And then you utilize it daily without having to do anything other than looking at the result that comes out of it. That will save you a lot of frustrations. You front load all of the frustrations into the development and avoidable mistakes, and also the boredom of doing the same things over and over and over again. And now let's think a little further. Imagine how useful that will be for 1,000 sensors distributed all over the place, and your ability to visualize results spatially on a map automatically day after day. We'll learn that here in this course. These examples are not grabbed out of thin air. There are seismometers all over the state, all over the country, same with GPS receivers. So this could happen to you quite realistically during your professional life. And if there's not a sensor out there, you might get data elsewhere. Now, PAG itself is an asynchronous remote course. As such, clear lines of communication are very important. We won't ever meet in a classroom, but it really works. It has done so for a few years now. Communications will be via Slack, a messaging tool for teams. This really is what we are. I do consider us a team. We, myself as instructor and the TA, guide you through the fall semester. We'll tell you about some cool things that you can do with a computer to help your science, etc. You will tell us how well it's working or not. If you have questions, you should ask us, and you should also engage with each other to help each other out and advance your ideas and learn the things that you need for your scholarship or your future work. Please use Slack as the primary and ideally only communication path for written communication with us. That way, nothing will get lost in my bursting email inbox, and it's easy for me to separate class communications from all the other stuff that happens in my professional life. It has worked really well in the past, so please engage with us that way. That said, there are other lines of communication. We have office hours that we're offering. There we can have some synchronous communication time. They will be Zoom only for this course because it is a remote course, so we keep things in Zoom land. All the links are in the syllabus. Computing for this class will be entirely on Open Science Lab, a cloud-hosted platform that only requires you to have a modern web browser and a reasonably good internet connection. You will not have to install anything locally on your machine. That is a real advantage because we, instructors, can focus on teaching you the material of the course. You can focus on learning the material, and nobody has to work on troubleshooting your installations on your personal machine. We really want to keep it that way. We do, however, invite you to explore installing JupyterLab, NumPy, etc., all these packages on your machine, but we do not have the capacity to help you troubleshoot your installations. The internet is a great resource for that. You can Google things, look at your error messages, Google them. You'll quite likely find very straightforward solutions. So we ask that you solve your homework problems, your class project, and the labs in Open Science Lab that we have deployed for you. Instructions on how to sign up come with the first course video. Open Science Lab has been developed by the Alaska Satellite Facility. We've successfully used that setup in several classes and class iterations by now. So I think this should be very successful for this course. We'll also use GitHub. This is traditionally a version control system, but it is also quite useful for content distribution. It is web-based, which means that you can explore content in your browser too. We'll provide you with some limited instruction only on how to use this tool during this course. We could fill many, many hours on the theory behind version control and the practicality of how to use Git and GitHub, but we can't really go into that. All right. We're really excited to have you here. Please reach out and communicate with us, whether you thrive or struggle. Especially when you're struggling, please reach out early. The earlier you reach out to us, the sooner we can find a solution and move you towards success, which we're really deeply invested in. So again, welcome and have a great fall semester at UAF.